Hey, what's going on? Welcome to another episode of Angular Air. I'm your host, Justin, and on today's episode, we are going to be getting into Angular and Electron. We have some episodes before on this, so I was always excited to get back to this topic. So let's get into it. We'll say hi to our panelists, then we'll meet our guests, and then we'll get into the content. Joining us today, we have Mike. Mike, what's going on?
Not too much. Just enjoying getting ready for a conversation about some chemistry, electrons and neutrons and protons, quarks, right? Quarks,
All
subparticles.
right. That's good. Yeah, we'll have to find out that answer too. If that's, I'm assuming that's probably what it was named off of. But yeah, good point.
I'm trying to showcase my high school science. Go me.
There you go. There you go. I forgot all mine. Bonnie, what's going on, Bonnie?
Whole lot of nada. Happy Friday, everybody. It's good to see you. Good to have Aristeidis on the show. Oh, so see, I did it again. I was so good about that. I haven't spoiled a guest in like months.
But
I'm just so excited about this guest.
It's quite all right. That's why I set you up to be the last panelist to introduce. So then you're
so
free to
me,
go ahead
Justin.
and do that. Yeah. Well, why don't you continue on? Introduce our guest.
So I actually poached this guest from my friends at the Dutch Angular group. Jeffrey had him come on and teach about Electron, and I saw that show, and I just went to Jeffrey and I was like, "Hey, can I steal your guest?" And he said, "Yes, you can." So then I grabbed him and brought him over here because it was a really great episode. So I thought everybody would want to see it.
Nice. Well, we are very happy to have Aristides on with us today. How's it going?
Hello, everyone. Thanks very much. I'm fine. How about you?
Doing great, doing great. Like Bonnie mentioned, it's a Friday, so we're excited about that. And we got Angular Air, and we got an awesome topic with Angular and Electron, and we have you. So everything's great right now.
Yeah, I'm not going to talk about electrons, as Mike said, but I will do my best to explain what electron is about and how to integrate it with Angular.
Nice, nice. Well, do you want to start off by telling our viewers a little bit about yourself?
Sure, yeah. I work as a front-end web developer at Plex.Earth, a company here in Greece. I'm from Greece, particularly Athens, which is the capital of Greece. I'm a co-organizer of the Angular Athens meetup, and I also work as a contractor in a company called Code Hub, where I teach other developers and individuals the Angular framework and what one can do with this awesome framework. And lastly, but not least, I'm the author of a new Angular book called Learning Angular 3rd edition.
Very nice, very nice. And is that we can get some more details about that book? Is that a hard copy book, digital copy, both out now?
Yeah, there are both types of copies. We have the print copy and Kindle format. And today, who for those that attend the show, I will give a discount promotional code of 20% to go and buy my book. I will give details about this later in my slides.
Nice, nice. All right. So our viewers have some additional excitement today. Perfect. Very cool. And you mentioned it's a 3rd edition. Is that correct?
Yeah. I wrote the 3rd edition. There are other two. Yeah, it's a series of.
Nice. Very cool. All right. Well, what do we got for us today, topic-wise?
Sorry?
What do you have for us today,
Show
topic-wise, for the Electron stuff in Angular?
Oh, yeah. Today, we're going to see how we can create desktop applications using Electron and how we can integrate an Angular application using Electron. I will start off with explaining how we use it in our company to build a map editing tool. And then I will show how to use similar techniques to integrate into your Angular application. We will have some slides, and then most of the time will be coding, which is the most fun part.
Nice. Definitely. Well, do you have slides right now you want to kick off with?
Yes, I would like to share my screen right now.
All right, we see it.
Thanks a lot for the feedback. So today we're going to talk about how to create, sorry, hold on a minute, please, to adjust my slides perfectly. Okay, so today we're going to see how to create desktop applications using web technologies. And when we say web technologies, we mean HTML, CSS, and JavaScript. More specifically, we will see how to integrate two awesome JavaScript frameworks, Angular and Electron, to create a desktop application. So, in detail, we will see how we use Angular and Electron in the company that I work for, in Plex.Earth, to create awesome Angular applications. Then we will go through a brief overview of the Electron architecture. And finally, during the coding time, we will see how to render an Angular CLI application as a desktop with Electron and how to pass data between the Angular and the Electron application. So I will skip these slides because already we talked about that with Justin. And I would like also, this is the promotional code that I was talking about to you before. All you have to do is go to amazon.com or packedpub.com, log in with your account if you have already. If you don't have, you can create one. Then search for the title of the book, Learning Angular 3rd edition. Click on the button buy, and then you can enter the promotional code, which is here, 20 Angular, and you can get a discount of 20% of the book. Now, please notice that this discount code will be valid until 15th of December. So I will put it for some seconds on the screen so that you can get the information.
Nice. And I'll throw it up here as well in the bottom there. And I put it in the chat too, so everybody can get it there as well.
Thanks, Justin.
Cool. Sure, no problem.
So, as I told before, I work as a front-end web developer at Plex.Earth. Plex.Earth is the main product of a company called Plexscape that enables civil engineers and architects to visualize their 3D projects, their architectural projects, to visualize it in the real world. For example, if you are a civil engineer and want to, and you create a building, you design a building, and you want to see your building inside Google Earth or another map provider, you can use Plex.Earth to bring the Earth inside your CAD software, or go your 3D model inside Google Earth or the other map provider. It works both ways. So actually, Plex.Earth, what is it? It is a plugin that works with most of the well-known CAD software. For those that don't know, a CAD software is a software that civil engineers and architects use to create, to design 3D objects, models, buildings, cars, and stuff like that. Even when you want to design, for example, a circuit for the Formula One, you can use Plex.Earth. Actually, the circuit team of Formula One is one of the biggest customers of our product. So, as I told you, it works with all CAD software, and it works as a plugin. For example, in this image, you can see Plex.Earth inside AutoCAD. AutoCAD is the most popular CAD software in the industry. So, to sum up, Plex.Earth is the first hybrid desktop cloud-based software that was ever developed by Plexscape, and it is targeted for architectural, engineering, and construction industry. Most of our clients, about 95%, are in the USA and Canada area. And as I told you, the most well-known customer is the circuit team of Formula One and many construction companies. So Plex.Earth has Plex.Earth has many basic features. One of them is that you can import satellite images from map providers inside AutoCAD and other CAD software, as I told you. So, for example, we have three ways to accomplish this task. The first one is that we use some core providers that have their own satellites or small aeroplanes, and they can take satellite images by themselves. For example, as you can see here, Digital Globe and Hexagon are some of these core providers. The first way is using some intermediate providers like Google Maps or Bing Maps and get the satellite images from them. Now, these intermediate providers, usually they don't have their own satellite images or planes, so they use the core providers above to get these images. And the third way is using Map Explorer. Map Explorer is an application, a custom proprietary application that we have developed in-house Plex.Earth that allow us to create custom maps from the other two providers. So, what is a map actually? Because I'm talking about maps for about 10 minutes and some of our viewers may have a different perception of what a map is. Okay, if you're a normal person, you see a map and you say, okay, this is a map. Or if you go into Google Maps, you can see that there are some point of interest, and you understand map with one way. But architects and civil engineers understand the map in a different way. For example, suppose that you want to create a map that displays the United States of America, and each state will have a different color according to the result of the president that they vote. For example, if you have seen in the news these days, there is a map of the United States that has red and blue colors. So if you wanted to create such a map, what would you do? You could use Map Explorer and create three layers. So in the bottom, we call it the base map or the base layer. We put a map that covers the whole globe, the whole Earth. For example, Google Maps, Bing Maps, OpenStreetMaps. On top of that, we would put another layer or map that displays the borders of each state of the United States of America. But this map will be displayed only in the location of United States. It will not cover all the globe. And on top of that, we would put another layer that will display different color according to which president won each state. So you can think of a map as you overlay slides into a projector to display something on a remote screen. So we use Map Explorer to accomplish these tasks. Map Explorer is actually a separate application from Plex.Earth. It is built with Angular in the front end and Angular material and Electron in the back end. So the back end, there's no back end in this application. The back end is Electron. At this point, I would like to show you a video how Plex.Earth uses Map Explorer to import imagery satellite images inside AutoCAD to get a better understanding of what you can do with Angular and Electron these days. Okay, here we are inside the AutoCAD environment. This is Plex.Earth. So we open Map Explorer. Now, this is Map Explorer. This application is built, as I told you, with Angular and Electron. So in this application, we have already the base map, okay, that covers all the globe, and we will put another layer on top of that, which is called ESRI. ESRI is a very popular map provider. So you can see that the top layer covered the bottom layer, and then on top of that, we will put the layer that we want to visualize, our target layer, which is the railway network of a city. Sorry about the name here, it is in Greek. So the user can select the layer that wants to insert.
And these data sources, is that an external URL that you're putting in there, or where's that coming from?
Yeah, every layer is a different endpoint. So you are actually adding endpoints one on top of the other to create your overlaid content. These endpoints are, most of them are free to use, but there are also others that you need to register and get a username and password and to pay. So you can see here that the top layer creates only the blue lines. It doesn't touch all the map below. So we have already created the map that we want to import into AutoCAD. We can hide and we can show the layers so you can get a better understanding what is going on. And then we close Map Explorer. We return to AutoCAD. We select the area that we want to import these images into our project. And then Plex.Earth starts downloading the map inside AutoCAD.
That's really cool. And so then the tool is creating the separate layers as images and then bringing it into like AutoCAD. Is that what you were saying?
Yeah, that's right. Sorry, let me switch to my slides. Yeah,
So go ahead.
It actually creates a set of images, and then Plex.Earth inside AutoCAD put the images in the right order so that it can display the map as it is.
Very cool. So the tool is then going out and hitting, like you said, the endpoints to get the data, whatever's needed to build that visual display. And then the tool says, okay, now I've got all the data. I've built up the visual display. Boom, export them as images and use them in this external tool or external application like AutoCAD.
Yeah, that's right.
Nice.
And without ever using a backend API. That's really cool.
Are you able? Yeah, the path for things drawing that you see there in terms of like, so going back to your example of the U.S. election, coloring things red and blue. Do you have predefined like shapes, and each shape being, say, a state that you can then programmatically color? Is that something that's built within that tooling to be able to say, hey, I want to be able to draw this shape that happens to be Oklahoma? That's a shout out to Alyssa, who's not here today. To be able to draw this state of Oklahoma and say, all right, I want to make that one blue or red or purple or add a label or something like that.
Yeah, the library that we use for map editing can do this, but actually, in our case, we're not follow this approach. In our case, someone has created the map that displays Oklahoma with red or blue, and then we can call the endpoint that corresponds to this map and get the image. So we're handling with ready images. We don't manipulate the images directly.
Okay, that's fair. So you have a service, or someone has a service that you're able to essentially get that image for, and then there needs to be something, because with the maps you can zoom in and out, that associates that particular image is this particular size overlaid upon the different layers, because you need something to be able to make sure that they're all in sync. Otherwise, Oklahoma may end up in the Pacific Ocean or something, which would be
somewhere in the sea. Map Explorer. I would like to say that Map Explorer is a tool for Plex.Earth. It works complementary to Plex.Earth. Plex.Earth can edit the images. For example, if you download the map as we see, then Plex.Earth can edit the image and do all these customizations that you were talking about.
That's very cool.
But the very fun thing and the very interesting is that you can't imagine how many maps are out there in the web. I mean, there are millions of them that you can do whatever you can think of it. It is a very interesting topic. Yeah, maps, they are very interesting. So
really quick, I guess like part of the concept here and the power of the Electron app is that you needed the ability to reach out to different, endpoints or whatnot and aggregate data back to build these images for your plugin to be able to use. But you needed to be able to launch and kind of run that from an app like AutoCAD or whatever, right? And so those are like native apps that are running on an operating system. And so with Electron, you can wire up those apps to launch another app, which is your Electron app that then contains your Angular app, to run it. So you can connect the dots essentially there and provide a solution to build your app in Angular, but run it and connect it to these other applications and systems for the whole ecosystem to play together nicely.
Yeah, that's you totally nailed it. I mean, that's the whole concept. This is why we wrote Map Explorer using Angular, because Map Explorer before it was inside Plex.Earth. Okay, Plex.Earth and Map Explorer was in the same bundle. It was a Windows application because Plex.Earth runs only on Windows currently. So we took the decision to rewrite Map Explorer again from scratch because our programming stack in company is Angular-based, Angular-oriented, heavily Angular-oriented. And we choose Electron because of that feature that you described, that you can, because you can invoke another application from another executable. But here, there is a major drawback in this interaction, because you have a window, you have an executable that calls Map Explorer, which is a different executable. So the question is, how do you exchange data between them? This process was very difficult to achieve. I don't want to go into much detail because there are a lot of technical details behind it, but I can assure you that it's not easy to pass data from between two different executables. And we finally managed to do it using old school file handling.
Yeah, makes sense. Cool.
I want to see the code.
Not yet. All right, so I told you that Map Explorer is built with Angular and Electron. Okay, Angular is very popular. It's a very popular JavaScript framework, but Electron is not so much. So what is Electron actually? It is a cross-platform JavaScript framework. That means that you can run it. You can run an Electron application in Mac OS, Windows, and Linux. And as I told you at the start, it is used to create desktop applications using HTML, CSS, and JavaScript. So the main benefit of Electron is that you can leverage your existing web skills if you're a web developer and create desktop applications without the need to learn a new desktop language, for example, C# or C++. So if your team is familiar with with the JavaScript framework and you want to create a desktop application, you should probably check out Electron. Now, the bad thing with Electron is its size. I mean, Electron applications are relatively large. And when we say large, in the order of 400 megabytes. And why is that? Because Electron is built on top of Chromium, Node.js, and V8 engine of Chrome. Actually, they contain a version of Node.js and Chromium embedded inside the executable. It is like you have a Chrome browser inside your executable. It would probably take the size very high. Okay, it's reasonable. So that is why they are very large. But many popular applications are built with Electron, such as Visual Studio Code. I suspect you know about Visual Studio Code, Slack, Skype, or WhatsApp. There are a ton of applications that use Electron. If you go to their website and check, the particular page about who uses Electron, you will be surprised. I didn't know that there are so many applications. So now that we get a taste of what is Electron, I would like also to point out here that Electron, as most things in JavaScript world, is an npm package. So you install it using npm install, but you don't install it in your dependencies, in the dependencies of your application or of your project, but in the dev dependencies application of your application. Why? Because Electron is not used runtime, but it is used to build your application. So you put it in the development dependencies. Now, an Electron architecture, the architecture of an Electron application consists of main basic processes. The first one is the main process, which is used for making heavy tasks and calculations. For example, if you want to interact with the file system, you will go through the main process. It is this process that provides access to the native resources of your system using Node.js API. For example, libraries like Crypto for cryptography or FS for file system interaction, they are provided inside the main process. The other process, which is the renderer, it is responsible only for managing the user interface. For example, you can think that it is a single index.html file, which is actually one file, as you will see later, that includes all your application assets or your JavaScript files or your CSS files. So for us, for Plex.Earth, the main process was the Electron side, and the renderer process was the Angular side. You can think of it like this. So the Electron architecture follows the Chromium architecture because it is built on Chromium. So an Electron application can have at most one main process which can communicate with many renderer processes. But please notice that each renderer process operates in complete isolation. You can think of it like the renderer processes are the tabs and the main is your browser. Think like this. Okay, each renderer process can communicate with another renderer process, but not directly. It is not it's not a good practice. So if you want to communicate from a renderer process to another, you would go through the main process. We will see later how you could do it. Right, let's see some code, as Bonnie said. How we create.
Danny wants to know, do you have time for a quick question?
Of course.
Danny wants to know if there's a way to make a smaller build of an Electron app.
No, you can't. There is no way. The Chromium is built inside. The Chromium is bundled inside your Electron application. Now that I'm thinking, there is one way. If you fork the Electron repository and create your own Electron version. But it's a bit difficult. About 6 months ago, Google had created an experimental library called Carlo, C-A-R-L-O. This library had the benefit that it give you the ability to create desktop applications, but using the browser of your system. It didn't have any embedded browser inside. So the executable was smaller, but unfortunately, Google abandoned the project. I don't know why. They said that they didn't have the resources, but we made a prototype in the company using for the Map Explorer, and I can tell that the difference in the size was huge. Yeah. Okay. All right. So, how we create an Electron application? Electron is a JavaScript application. It's a JavaScript framework. So, we will write JavaScript code. But as you can write JavaScript code, you can also write TypeScript code. It depends on in which stack you're more comfortable. So the main file in an Electron application is the main.js or main.ts for TypeScript, as we have the main.js entry file in an Angular application. So to start creating the Electron application, we need two objects. The first one, we need to import from the Electron library two objects, the app and the browser window. App is the global object of your application. You can think of it as your browser, as your window object of your browser. The browser window is an object that creates tabs. You can think that creates tabs, like you fire up your browser and you start opening tabs. If you're a developer, I think you will most probably have many tabs open in your browser. So you can think of it as it will be a tab inside your browser. So you import these two artifacts, and then you create a function that is called createWindow. This function uses the browser window constructor, and it passes two properties, the width and the height. These properties define the size of the size of the window of the desktop application. Browser window has many properties that you can set. If you go to their website, they have, you just scroll, and there are many of them, a ton of them. So, the most essential are the width and the height, so that you can define your window. And then, after you have created your window, you call the method load file, and you pass an HTML file. This is the HTML file that you want to load inside the window. There are other alternative techniques. For example, you can start an Express server, Express in Node, and you can use the load URL method of the main window and pass the URL of your Express server. But in our situation, in Map Explorer, we didn't want to go with the load URL because we didn't want to create another resource in the system, because if you start a web server, you will have another resource in your task manager. So it is like loading a file from the file system. You can think of it like that. Now, this index.html, I will show you later, maybe is your Angular application HTML. Just a thought. So after we have created the window, we need to call this function. And when do we call it? When we want to make sure that we can call it when our application is ready to create windows. Now, the app object has a when ready promise that when it is resolved, the app is ready to create windows. So we call this function inside the when ready resolve of the promise. So this is the minimal code that you use to create an Electron application, a desktop application using one HTML. Now, notice that the Electron application does not care what this HTML has inside as a content. For example, maybe you load a ton of JavaScript files, CSS. It doesn't care. All that it cares is that it needs something to show, an HTML or a URL. So, some considerations that you should take care of if you want to create your own Electron and Angular application, or generally if you want to create a desktop application with Electron. Now, the first one is that, as in our case, when we started writing Map Explorer, we would like to achieve a specific task. Okay, suppose that you are a civil engineer, that you're sitting in front of your office on your desk in the company that you work for, and you have AutoCAD and you want to import a map, as we did earlier. So what would you do? You would open Map Explorer, create your map, select it and download it. Now, this map maybe have been created from another person, from another user, maybe an administrator, and the administrator, maybe he have used a different interface, a web interface to create that map. So you can see that we would like to have collaboration between different types of users, end user and administrator, and different types of environments, desktop and web. The first consideration is that the first question that you need to answer is whether you will have a backend or not, because in our case, Map Explorer doesn't have a backend API, a backend REST API. Okay. All data of the user are kept inside the local file system using JSON files. We don't have any HTTP endpoint. So we say that it is a kind of serverless. But okay, serverless is something different, but we like to say that we are serverless. The third and the most important consideration is something that I talked about previously with Justin, is how you communicate between your desktop application and another one. Okay, because this is very hard to accomplish with the tools that there are now in the community and in the web. We have used many approaches. We have used SignalR of Microsoft. We have used a toolkit called Akka that you can run Node.js inside C#. But none of them proved very reliable. So we ended up with simple files. So Plex.Earth, for example, opens Map Explorer. Map Explorer creates files in the file system and then notifies Map Explorer that the images are ready to hand it over. Currently, there are some libraries that emerge right now that use the standard input and standard output, but they are not ready for production yet. So, okay, we saw how we create an Electron application. Now, the most important part inside the Electron application is how you communicate between the main and the render process. For example, how you would communicate with the Electron code and your Angular application. Okay. Now, Electron has a global object called remote that we can use to accomplish this task. And what it does, it actually in the main process attaches in this global object a variable, maybe a library or any other variable. Okay, for example, here we attach in the global object a variable, which is the FS, the library for file system handling. And then in the render process, we can import Electron, access the remote object, and get this global property. Now, can you see anything suspicious in this code? Maybe Justin that smiles.
Well, I see the require.
Yeah.
So is this code at the bottom then the code that we would have like in our application?
Yeah.
Angular
The bottom is the Angular, the web applications. The top is the Electron application. I mean, what we are doing here, we are actually exposing our file system to the web application. We are exposing our file system. That's not right. I mean, we shouldn't do this. At this point, I would like to mention something. An Electron application is a web page, so it has all security problems and considerations that a web application has. So we must be very careful what we do when we use Electron. Any attack that someone can do in a web page can also do it inside an Electron application. So this approach with the remote object should be avoided. It is there for someone to use it, but as a general notice, it should not be, you shouldn't do it because it is dangerous. In the end of the slides, I have a list of resources. There is an article from Medium that describes why the remote object is harmful. So you can check this out at the end. So,
yeah, because one of the things about a browser, running in the browser has limited access to the machine, right? In terms of what the running code in the browser could get to on a individual's actual physical machine. And so Electron is like opening the door to allow your application to get in there and do those things at that, file system level, at that system level. But like you're saying, with that opening that door, you still need to think about the fact that ultimately you are running your browser-based code. And so you want to adhere to the concept of a browser, and the security around that.
Yeah, many people don't think about. They say, okay, desktop application, what could go wrong? But many can go wrong because it is not a desktop application. What I like to say is that Electron is a web application disguised as a desktop one. So, as a general notice, you should avoid using the remote object. If you already use it, there is a property which is called enable remote module. It is inside the web preferences option of browser window, and you can set it to false to avoid to prevent the render process from using the remote object. Luckily, in the last version of Electron 10, this option is disabled by default. So if you create a new Electron application now from scratch, the remote is disabled. So we all understand that there are many security considerations. If you want to learn more about what could possibly go wrong in an Electron application from the terms of security, you can check out a talk that I did in the Real Talk JavaScript podcast about how to take security considerations when building Electron applications. Okay, Aris, we should not use remote. What we should do? I want to get my Electron application ready now. Right. You could use the IPC communication technique. This technique allows you to exchange messages from the main process to the renderer and back asynchronously. The remote object that we saw previously was synchronous. This one is asynchronous, and it does not expose something on the renderer. It is considered safer than the remote. So, how would we do it? In the main process, we would use the IPC main object from Electron, and we would call the handle method. The handle method, you can think of it as the add event listener method that we have in JavaScript. So we call the handle method, and we pass the name of the event and an arrow function. This arrow function will be executed when someone calls the get data event. Now, in the render process, we will again import the Electron, and we will use the IPC renderer object, which is similar to the IPC main. This renderer process has an invoke method that is used to call the event that we created here. If you want to pass arbitrary data to this method, you can use the second parameter after the name of the event to pass anything you want. So this is the way that you should follow to communicate between the main and the render process in your application. You can see also that we use here await async syntax. Why? Because IPC communication is promise-based. So Electron uses Chromium. Async await is supported in Chromium, so you can write your application using async await, and you don't need to use observables. for an Electron. For the Angular application. I mean, in Map Explorer, when we built Map Explorer, we didn't use any observables, as you will see later. We have only promises and used async await syntax everywhere. So your code is more readable. Right, so let's see some real code now. Let me switch to my code. Okay. I hope you find it interesting so far.
Yeah, definitely. Definitely.
So,
Do we have time for another question, Aris?
yes, always.
Justin, will you put that question from David up? How do you configure a CLI application to use Electron-specific APIs and Node APIs without getting type and build errors? That's a good question, David.
This is what I will show right now. We will see an Angular CLI application that uses Electron APIs.
That's a perfect segue.
Sure. So I have created an Electron. Wait. Hold on. I have created an Angular CLI application. You can see from the structure that it is an Angular CLI application, Angular CLI 10 especially. The structure is the same. So let's run it. Usually, I would like to show you a tip here. When I'm working with Angular CLI applications projects, I use an extension called NX Console, which is very convenient when you want to work with, when you want to build, serve, test, and stuff like that. This extension has been created from the Narwhal team, and it is actually a wrapper over the Angular CLI. So you can see that it has the generate command, the run, build, everything the Angular CLI can do can be done through the NX console. So if we go to the serve, it prompts us to select the project that we want to serve. And NX console is part of the NX toolkit, the whole NX platform, which is based on monorepo. So if you have many projects inside your monorepo, you could select which one to serve. Now we have only one. When you can see here that it has all the options that the Angular CLI serve command supports, and there are also descriptions, and it explains exactly what each command does. So you don't need to think by heart. You don't need to remember by heart what each command does and which option. So we press run. The run executes an ng serve onto our Angular application. It starts compiling. The first compilation is always slow. Okay, so we open the browser. So you can see here that it is the minimal Angular CLI application that you get when you create a new Angular application from scratch. You can see the styles, here the icons. The real difference is that I have rendered here a list of pirate names. I choose pirate because I'm a huge fan of the Angular, the Assassin's Creed series, and especially the black flag, as you can see below me with the flag. So pirates is my theme. It's my favorite theme. So we render a list of pirates. If I open my network tools and make a refresh, you will see that these pirate names are loaded from the pirates.json file, which is inside the assets folder, and I chose to get them using HTTP. Okay. If I open it, you can see here, it's just a list of strings. So here, the HTTP client is involved. Let's go and see the code. If we go to the folder here, to the structure, inside the source folder, we can see the app folder that contains our app component. The app component uses the pirate service to get the pirates. If we go to the pirate service, it uses the HTTP client to fetch the data from the assets pirate.json. And surprisingly, I use the toPromise operator, ArcJS operator, to convert it from observable, because HTTP client response is observable based, to convert it from observable to promise. And why I do that? Because in the component, then I can go and get it as await async syntax. Okay, that's fine. I mean, there's nothing very special in this application. So, how we could take this application and render it as a desktop application using Electron? If you see here, we have another folder called Electron. It is better to keep the Electron and the Angular application in different folders so that it is more manageable and testable. If we go to the Electron application, we can see there is a main.ts file. Now, this file, it looks like the code that I showed you before. It has the create window method. We create a new browser window with some properties. We load the file index.html, and then when it is ready, we create the window. So let's see how we can run this. If we go to the package.json, we have two start commands. The first one is the standard ngserve command of the Angular CLI. But the start Electron command is different. What it does, it builds the Angular application, and then it builds the Electron code, and it outputs into the same folder. So you will have the Angular bundle and the Electron bundle inside the output directory with the index.html. Why we do it inside the same directory? Because if you see in the main.ts, it says load file index.html. This index.html is the Angular application. So if you are in the same folder, the Electron code can find the file and load it normally. Okay? So let's run this script. There is a very nice add-on here in VS Code, which is called npm scripts, and you can run it directly from here without ever touching the command line. I love this add-on. So if you press Start Electron, first it will build the Electron application, and then the Angular. You can see here, this is the Electron application. It is called cell.js. Notice that we are in TypeScript land. So our main entry point file of the Electron is main.ts, not main.js. So we use Webpack to convert the main.ts of Electron to a JavaScript file. And why do I name it as cell.js? And why don't I leave it as main.js? Because they are in the same folder. And if I build the Angular application, it will create a main.js. And if I build again the Electron application, it will overwrite my main.js. So I give it another name. Now, this start electron is for development only. Okay, so we can see on the bottom that the Angular application has finished. If we now go to the run menu of VS Code and press start electron and cross the fingers, yes.
You have to pray to the demo gods.
Sorry. Yeah, I have prayed to them a lot of times. Once they didn't hear me. So you can see here, it is our Angular application rendered inside the desktop window. How cool is that? If we go to,
It's very cool.
If we
That's
go to
cool.
View, Toggle Developer Tools, I have a whole Google Chrome browser inside my desktop window. This one that you see here, it is Chromium. Okay, so we have all the goodies of the Chromium browser. We have elements. Let me make it larger. Sorry about that. We have elements that we can inspect. We have the console, and we have the network. Now, I will show you something interesting. I'm here in network. If I reload my application, let's do it again. If I reload my application, did you notice something?
Where are the pirates?
They're gone. Now, there is a big difference from the Angular application. Now, we load the pirates.json from the file system using Node.js. We don't use the HTTP client. Let's see how do we do this. Let's close that. One small detail that I didn't show you yet is that I built the Angular and the Electron code inside the same directory. But the Angular CLI, when you build it in serve mode, it overrides, it deletes your folder. If you go to the package.json that we saw earlier, you will see the command that we ran earlier. Okay, you will see that we built the Angular application using a specific configuration, and we pass also the delete output path to false. Because when you build with Angular, every time you make a change in your code, it deletes the directory and rebuilds, and it outputs the new bundle. So the start electron is executed in watch mode. So you have the Angular application serve in watch mode, the electron code in watch mode. If you make a change to the Angular application, the Angular CLI will delete your folder. So we pass this specific option to prevent that. So I told you that we also use a different configuration, which is called Electron. Why do we use this? If we go to let me see. Right. If we go to the app folder of the Angular application, we have already seen that it has a pirate service, but also it has a pirate local service. Now, why do we need this service? If I open it, you can see that it has the same signature as the pirate service, but it doesn't use the HTTP client. It uses the Electron service. The Electron service is part of a library called NGX Electron, that it is a wrapper of the Electron API. So with this library, you can use you have access to the Electron API as an Angular wrapper that you asked me, Bonnie, before. I think this answers your question. So we inject the Electron service, and then instead of making an HTTP GET request, we use the IPC renderer object, and we specifically call the invoke method passing the name of an event. Do you remember the IPC communication that I showed you before? This is what we're talking about right now. So in the Angular side, we use the IPC renderer to invoke a specific event. Right. Let's go now to the Electron side. In the Electron side, we have created an event using the handle method of the IPC main called getPirates. Be careful, the name of the event must be the same in here and in the renderer. Okay, so when someone calls the getPirates event, we use the FS library of Node.js to read the pirate.json file synchronously, and we return it as a JSON array, just like HTTP client does, roughly. Okay, so with this way, we managed to communicate between the main and the renderer process, or in other words, between the Electron and the Angular code. So you can, in this way, you can have one team working in the Angular code and do the stuff that knows, and another team working on the Electron code, which is, if you think about it more, it is like the backend team and the frontend team. Okay.
Yeah, it makes sense. Because you're really here saying, look, the Angular app is going to support where it gets the pirate data from. And depending on the build of the deployment where you publish it to, it's going to get configured with that destination source for the endpoint or the backend part that provides the pirates data. And in the case of Electron, like you showed, it comes from the Electron app accessing the file system or whatever it decides to do. And when the Angular app runs in the regular browser, it's from this JSON file or maybe from another endpoint, that sort of thing. Yeah, very cool.
Right, yeah. Okay, so we saw how to serve an Angular CLI application. Okay, that was the easy stuff, the easy bit. We saw how to render it as a desktop application. Now, if I tell you that you can build your Angular application in either modes, would you believe me? Yeah.
I would believe you.
That is why I'm here today, to make you believe.
Now I gotta call one thing. We're at the top of the hour, so we actually got to wrap it up. So we might need to have another episode, a follow-up episode, because we do have to wrap up right now. But is that something you can squeeze in here quickly?
Yes.
Okay,
I think that's important enough to try and squeeze in.
Let's do it.
Okay, so the really cool part is that you can build your application for both web and desktop using this one, the providers. So you use the provide object literal and you define a factory. If we go to the factory, there is an environment. You define an environment. You say, now my environment is desktop, or now my environment is web. And you say, if my environment is desktop, then you create the pirate service with HTTP included. If you're in the desktop environment, you create the pirate local service with the Electron dependency. Now, these two have the same signature, okay? The same signature, exactly. And because the IPC renderer communication is promise-based, in the component, I didn't change anything. I just defined a new service for my Electron code. That is the top of the cake.
Yeah,
so
very cool.
I have this code. I have this code on the GitHub. You can. I have the link in the end of the slides, in the resources. You can download it. I have put comments in all the bits that I didn't show you today. For example, in the Webpack configurations, which is more, it is a more complicated part. And with that, this is the end of the slides. This is my communication links, the resources that you can check it out. I will share it with you. Yeah. If you want, we can see some details about later in the after show event.
Yeah, we have so Aris is coming with us to community hangout on Angular Nation like right now. We're actually late. So we can have more questions over there as well.
Okay. Thanks a lot. Thanks very much for the invitation. Thanks Bonnie for your tips about the presentation. They were very helpful. And thanks Justin for the communication. You made it very comfortable for me and very easy. And nice to meet you, Mike. Didn't know, I haven't met you before, but it was great to see you all, guys.
It's great to have you.
Coming on and showing us.
Yeah. We
Thanks for
appreciate
teaching
it,
us cool
Aristeidis.
stuff.
Yeah, for sure. Thank you a ton for sharing your time and coming on here and sharing your content. Like Bonnie said, Mike said, we super appreciate it. And that's if you want to, let's schedule another follow-up episode and we can dive deeper into it if you like. So just reach out to me, let me know. We'll put that on the calendar if you like.
That would be great. Yeah, I would like to see some more code. Yeah,
for sure. Well, thanks again. Like Bonnie mentioned, both of you heading over to Angular Nation, follow up on that. So check out that out. And that's a wrap. So thanks, everyone. Catch you later. See ya.
Bye.